So I'll spend a little bit more time here talking about the ellipse than I did with the circle or the parabola, because this is not one that you really see in any high school course until you actually study the conics. And if you understand ellipses, hyperbolas are almost exactly the same mathematical approach, because mathematically an ellipse is a hyperbola. I'm sorry, a hyperbola is an ellipse that we've turned inside out. So the big idea here is we have what's called a major axis and a minor axis. The major axis determines the direction of our ellipse. So a horizontal major axis means that the longer axis, what we call the major axis, is horizontal, which gives us a shape that we're a little more used to thinking of, like this. Not sure why my pen is having so many issues right now. And then vertical axis, like this. So the key to this is, first of all, identifying whether we have a horizontal or a vertical ellipse. And so what we look at here is if we are in the vertex or the center form, vertex form, foci form. I've heard this called many different ways. Here we have what you want to look at is which denominator is larger. So being an ellipse, these should always be addition. If they were subtraction, these would be hyperbolas. But whatever the larger number is under will tell us if it's horizontal or vertical. So if the larger number is underneath the x's, it's horizontal. If the larger number is underneath the y's, it's vertical. So A is referring to the distance from the center, and our centers will again be at h and k, the coordinates, because we're moving x, right h, and up k, right h, up k, or left and down if we have different signs for those. But then A refers to the distance from the center to one end of the major axis. And then B is going to be the distance from the center to one end of the minor axis. And then C is not a number that comes up within the equations here. We actually use Pythagorean theorem for C. C is going to be the a squared plus b squared equals c squared. And that is going to be the distance. I have that messed up. That's not supposed to be plus. That's supposed to be minus. A squared minus b squared gives us c squared. And it has to be minus because our foci need to be closer to the center than the ends of the ellipse, because the foci are inside the ellipse. So a squared minus b squared will give me c squared, where c is the distance from center to focus. So first off, if we're given an equation like this, where it's not in the form that we're used to seeing like here, and this is being called standard form, first, because both are being squared, it is not a parabola. And then because I am adding them, but they have different coefficients for this x squared and the y squared term, so that it is not a circle, which is what makes this an ellipse. And to be an ellipse, I want x squared and a y squared both being added together, but they have to equal 1. So to get it to be in the form I need, I have to divide everything by this 36 in order to get to the vertex or center form for this. So that would give me x squared over 9 plus y squared over 4 equals 1. So now what this tells me is, because 9 is larger than 4, that tells me a squared is 9, b squared is 4. So a is 3, b is 2. Then c squared would be a squared minus b squared, which is 5. So c is going to be the square root of 5. I can also see, so this is going to be horizontal. I can even see that the center is going to be at the origin, 0, 0, because I didn't move my x's or y's at all. So if I wanted to graph this, I graph the center. Horizontal, because the 9 is under the x squared, I'm going to move 3 from the center, both to the right and to the left. And then that determines the width of my ellipse. And for my minor axis, I'm going to move up 2 from the center and down 2 from the center. And those are the top and bottom of my ellipse. And now I just can connect those to get a graph of the ellipse. But then for the foci always lie on the major axis, so I'm going to go in the same direction as I do for the A. So because I moved left and right for A, I have to move left and right for C. So my foci, if I go from the center right, square root of 5, which is a little bit more than 2, I have square root of 5, 0 for one focus. And then if I move left from the center, the value of C, I have negative square root of 5, 0 for my other focus. And those are kind of the big things that we want. Sometimes we'll be asked, how long is the major axis? Well, if I went 3 from center to one end, that means 3 from center to the other end. So total length of the major axis is 6. Total length of the minor axis would be 4. Distance between both foci would be 2 times the square root of 5. But for the most part, it's really we want center, we want the foci. So that's what really determines the shape. Because by definition, an ellipse is points that are equidistant from the sum of the distances from two points that we call the foci. Now, if we go a little bit more complex, then you have the lovely cases of what if we are dealing with having a complete square. So something like this. I have two squared terms, so this is not a parabola. I am adding, so it's either a circle or ellipse, but the coefficients for the squared terms are different, so it is an ellipse. So I need to first get things so that my x's are all together. Leave a blank, and then I need to get all my y's together. I'm going to move the 400 to the other side. Now, the drawback of completing the square technique is if I have a coefficient in front of the square term, I can't actually complete the square that way. So I'm going to factor out the 16 from the x's. I'm going to factor the 25 out from the y's. Now I can work on completing the square. So negative 10 divided by 2 is negative 5 squared is 25. And 8 divided by 2 is 4 squared is 16. But now when I am adding these to the other side, I have to realize I added a 25 that was inside of something I multiplied by 16. So I have to do 25 times 16, which is 400. And 16 times 25, which is another 400. I'm adding two 400s here. So what I now have is 16 times x minus 5 squared plus 25 times y plus 4 squared equals 400. And then I have to make this equal 1, so I have to divide everything by 400. Which leaves me with x minus 5 squared over 25 plus y plus 4 squared over 16 equals 1. So this ellipse is horizontal. Its center is at 5, negative 4. I know it's horizontal because 25 is the larger number and it's under the x's. So that means A is going to be 5, B is 4, and C, which I need for the foci, well, C squared is going to be 25 plus 16, which is 9. So C is 3. Because it's horizontal, that means I'm moving left and right from the center. So my foci, if I move to the right, that's going to be 8, -4. If I move to the left, that's going to be 2, -4. And that's pretty much all the information I would need then, because from the center I'd move right 5 and left 5 to get to each end of my ellipse. I'd, from my center, go up 4 and down 4 in order to get to the ends of the minor axis to get the rest of my ellipse. So then the last way that example I saw in there that involved ellipses from your questions was they gave us the foci and they gave us like the major axis and said basically find the equation of the center or of the ellipse. So things I can tell from this. The center must be halfway, is the midpoint of the foci. Because if I move from the center the same distance each direction. So I can tell from the foci that my center is going to end up being 0, 0. I can also see that C is going to be 2. Because remember, C represents moving from the center to one of the foci. And I move 2 units from the center to get to the 2, 0. I move 2 units from the center to get to -2, 0. I can also tell, because we moved left and right, that this is horizontal, which means that my A squared is going to go underneath the X, not the Y. But then length of the major axis, I'm told, is 10. Well, the major axis is going, that length is 2 times A. So I know that A is 5. But I also know that A squared minus B squared equals C squared. So 5 squared minus whatever B squared is has to equal 2 squared. 25 minus B squared is equal to 4. So that means that B squared is 21. I actually don't really need to know what B is if all I'm doing is writing the equation, because the equation just uses B squared. So then when I go to my form of the equation for a horizontal ellipse, I actually now have all the information I need. I know H and K are both 0 because that's the center. Always going to equal 1. I know A is 5, so A squared is 25. And I found that B squared is 21. And there is the equation for our ellipse.